steady state gain. So what is steady state gain? Suppose if you take, let's say, y by x, kp by tau s plus 1. This kp is called as steady state gain. So next question is how to find steady state gain. How to find steady state gain? So what you do is, this is a system. Let's say kp by tau s plus 1. This is x, this is y. Suppose if you give 1 by s in x, then what is y? What is y equal to kp into 1 minus e power minus t by tau. So what is y of infinity is kp. So basically what does this mean is, if you change the x by 1 unit, if you change the x by 1 unit, y is changing by kp units. If you change the x by 1 unit, then y is changing by kp units. So this is steady state gain. So how to find steady state gain is, give a step change in the input and see how many units the output is gaining. Is nothing but the steady state gain. So give step change in the input and see how many units the output is gaining. Is nothing but the steady state gain. Understood? So for finding out steady state gain, what you should do is give a step change in the input and find the ultimate value of the response. See how many units the output is gaining. Is nothing but the steady state. Solve this problem. So what is the steady state gain of y by r? Have you understood the concept of steady state gain? So does everybody understood the concept of steady state gain? So basically what is steady state gain is, if you change the input by 1 unit, how many units the output is changing is steady state gain. This is 2 into 1 plus 0.2s. Four by 9. Input here is steady state gain, means by default input is 1 by s. What is steady state gain is, if you process unit change into the system, how many units the unit system will gain. This is property of the system. Like if you see, thermometer has a steady state gain of 1, whereas liquid level tank has a steady state gain of R. 4/9 answer. Derive the transfer function. So for derivation, let us assume that this is G1, this is G2. Let's put one variable here. Y2A is a standard loop, right? Y2A is a standard loop, correct? So I can write Y2A as Y by A as G1, G2 divided by 1 plus 0.2 into G1, G2. What is A? R into 0.2 is nothing but A. So you put A equal to R into 0.2, then what will become is Y by R is equal to 0.2 into here. So now put R is equal to 1 by S. Then what is Y? 1 by S into 0.2 into this is Y. Now what is Y of infinity? What is Y of infinity is limit S tends to 0, S into 1 by S into 0.2 into G1, G2 by SS will cancel 0.2 into G1 of 0, G2 of 0 divided by 1 plus 0.2 into G1 of 0, G2 of 0. Now here, what is G1 of 0? What is G1 of 0? If you put S equal to 0, then this is 2. What is G2 of 0? Is also 2. So if you put here, then what is Y infinity is 0.2 into 2 into 2 divided by 1 plus 0.2 into 2 into 2, which is 0.8 by 1.8, which is 4 by 9. So this steady state gain is 4 by 9. Yeah, for final value theorem gives steady state gain, correct. Does everybody understood the concept of steady state gain? So we'll move to next topic, which is control valves. Control valves. Just I'll share one snapshot. Just look at that one. Can you see this one? So this is called as two types of valves we have. One is air to close, another one is air to open. So in air to close, what happens is if the pressure applies, so air, let's say, so can you see this markup? So you apply the air pressure here. So this is where you have the air. You apply the air pressure here. Then when the springs comes down, so applying air pressure closes the valve. So see if pressure increases, valve or let's say opening decreases. Clear? So if pressure increases, opening decreases. This is air to close type. Whereas air to open type means if you keep on applying the pressure, the valve will starts to open. So maybe I think we will draw this diagram and then so I'll draw this diagram on white. air. This is how flow. Is this air to open or air to close? If you apply the air pressure, then walls moves in the downward direction. Then the opening closes, no? Then the opening closes because this is the opening where which is available. Opening available. So if the stem comes in the downward direction, then the entire wall closes. So that is air pressure increases, wall closes. So this is why this called as air to close. This type of valve is called as air to close. The air pressure is in the range of 3 to 15 psi. That means for 3 psi, for lowest pressure, what is the position? Valve will be 100% open. For 15 psi, the maximum pressure, the valve will be 0% open. So if with the air pressure, the valve closes. Now imagine the scenario of our CSTR example. Suppose if the temperature of the CSTR is increasing, then what is the cooling water valve? Should it open or should it close? Let's say temperature of the CSTR currently 60 degrees, and then valve open will be, let's say currently, let's say 60 degrees is the temperature of the CSTR. And then how much flow rate we need? Cooling water, what we need is, we have discussed this problem. What we need is 1 ton per hour. For 1 ton per hour, the valve opening required is 30% opening. Suppose if the temperature of the CSTR is 65, then what is the valve opening? It should go high because you need more cooling water. So the valve should go to 35% opening. Now, for going from 30% to 35%, the controller should send increase. Let's say 30% open corresponds to, let's say, 7 psi. The controller gives the pressure signal, no? Should send, so let's say 8 psi or 6 psi, or let's say should send 8 psi if valve is A to open. Should send less pressure signal if valve is A to close. So this is how the controller works. So what comes out of the controller is a pressure signal, no? Now this is my steady state. Let's assume that this is my steady state. This is my steady state. Now, going from the steady state, now let's say the situation has come, this and temperature of the CSTR is 65 degrees. Now when the temperature of the CSTR is 65 degrees, now the valve opening should go to 35% opening. 35% opening. Now for going 35% opening, should the controller send a higher pressure signal or lesser pressure signal? Depends upon the type of the valve. Whether it is A to open type or A to close type. So this is how the controller works. Did you get what is the feel of the entire system? So what is air to open type? Air to open type means you just put this, let's say this is air to close. So then air to open means the stem will be like this. Just understand for 2 minutes. I will draw another diagram for air to open. So have you understood air to open, air to close? So this is air to close because if air pressure increases, valve closes. And one more important point is, I will draw the air to open diagram. So with the minimum pressure signal, suppose if air fails, let's say if air fails, meaning that if you cut the air here, then what is the air pressure? Then what is the air pressure is 0. When the air pressure is 0, then what is the valve position? 100% open. 100% open. So this way, this valve is also called as failed failed to open. This valve is also called as failed to open, means If air fails, valve goes to open position. Air to close or fail to open. So that is why this valve is also called as fail open valve. Fail to open type. Now, how is the air to open diagram looks like? The flow will be something like this. This is air to open type. So if the air pressure increases, valve close, open. Air to open. Air to open. That means 3 psi valve is 100% close. So whatever I have drawn is now 3 psi position. Suppose if you go to 15 psi, then valve will go to 100% open. Yeah, the next. So this is what is the fail position? Suppose if air fails. Suppose if air fails, then what is the position of the valve? That means pressure is C. Pressure is 0. Then valve will go to closed position. So that is why this is called as fail close. Now these are the two types of valves. Now let's take a CSTR example. Now we will get one question, sir. Why do we should have, let's say, fail to open or let's say air to open a type of valves? Why not, let's say, single valve can work for our purpose? Is the question that we have. So let's try to understand. Air only, because these are pneumatic operated valves. Suppose if the valves are very big, in the plants, if you see some valves are extremely big, then air cannot operate that valves. Then using the motor that will operate the valves. They are motor driven valves. But rest of the things, mostly it is air operated valves only. This is the control diagram. That's a GC. This is measurement. This is operating the valve. Now, if you try to understand measurement, where is it sitting in the plant? What is this signal? This is nothing but a data cable which is carrying a current of, let's say, 4 to 20 milliamperes. 4 to 20 milliamperes. How do you calibrate this 4 to 20 milliamperes? Is, let's say, see the temperature of CSTR. What is the minimum temperature that it can get is 40 degrees, because the feed temperature is 40, no? What is the maximum temperature that you will get is, let's say, 100 degrees. How do you know 100 degrees? Let's say if the entire, if you do not remove any heat, then what is the temperature attained by the CSTR is 100 degrees. So at any cost, the temperature of the CSTR cannot exceed 40 and 100 degrees. So the 40 degrees will be assigned to 4 milliamperes, and then 20 milliamperes will be assigned to 100 degrees. That is how you decode the signal. That means, suppose if the plant temperature is 60 degrees, then accordingly it calculates 4 milliamperes corresponds to 40, 20 milliamperes corresponds to 100. So where does the 60 finds that much amount of current, it will pass through this particular signal. Clear? So this is a 4 to 20 milliampere signal, and then this is a set point that you are giving, and this is also a 4 to 20 milliampere signal, but which is translated into air pressure. So 4 to 20. What is air pressure? Minimum is 3, maximum is 15 psi. So that is how the controller works. Now the question is, you have two control valves sitting here. This is V1, this is, let's say, V2. So V1 and V2. Now how to select the type of valve? How to select the type of valve? Do you need air to close or air to open? How do you select? This is, how do you select this depends upon the emergency scenario. So you have to consider emergency scenario. In the plant, there is a concept called as emergency shutdown. Suppose there is a fire in the plant. There is a small fire in the plant. Then you can't shut down the entire plant. Like, suppose if there is a emergency in the plant, there is a small fire in the plant, then you can't operate each valve, no? If there is an emergency, what you will do simply is, you cut the air signal. You cut the air signal. Then the plant, when you cut the air signal, all the valves will not receive any air. All the valves will not receive any air. Suppose now imagine a scenario, cooling water. So you will have two scenarios when you cut the air signal. You can have, let's say, full cooling water going through the CSTR and no cooling water going through the CSTR. Which one is safe? Sending 100% cooling water to the CSTR is safe, or sending 0% cooling water is safe? Which one is safe? So let the cooling water flow through the CSTR. Now what will happen? It doesn't catch any fire. What happens if you send more cooling water to the CSTR? Is there any unsafe situation? No, because cooling water doesn't catch fire. And moreover to this one, if you send cooling water, if there is any heat which is accumulated in the CSTR, that will be taken out. So what we can say is, fail open is more safe than fail close. This doesn't mean that if you select a fail close valve, the plant, let's say the CSTR will break down. It doesn't, nothing will happen even if you don't send the cooling water also. But if you come to safety point of view, no cooling water is 99.9% safe. Sending cooling water is 99.91% safe. That means sending more cooling water is little safer than not sending the cooling water. So in emergency, you should not think about, I am wasting the cooling water, I am doing that, this kind of thing. So in emergency, safety of equipment is the utmost importance, because a small breakdown of the vessel will shut down the entire plant. So sometimes small pumps will also cause the plant to take shutdown. Suppose if you take a compressor, in the compressor there are small pumps inside the compressor which actually compressor generates the heat. How do you remove that heat is using the concept of oil, lube oil you call in the plant terms. That lube oil circulation is done by a small pumps which are sitting in the compressor. Suppose if that pump fails, that is a very small pumps. That is because cooling water you can't use it because the heat generated is extremely high, maybe 200 degrees. So water will become vaporized. So that is why we'll use lube oils. So that small pumps, maybe it is a, let's say, very small pumps. Maybe you can hold it with a hand. So that small pump, see, suppose if that pump fails, then what happens? You can't run the compressor. If you don't run the compressor, you can't run the plant. So basically, what I'm trying to say is even a small equipment in the plant, a small hand size of pump can take the shutdown of the entire refinery. Clear. So equipment safety is very important in case of emergency, because suppose let's assume that a vessel breaks down. To construct that vessel, it takes, let's say, 3 to 4 months, because you have to now now you have the vessel. That vessel has to be given to the vendor who will fabricate. That fabricated vessel has to come to the site. Then you have to erect in the site. So this all process will take 3 to 4 months. That 3 to 4 months is a production loss. So that is why in emergency, to save the CSTR or to save the CSTR, fail open is more safe than fail close. So that is why I select here fail open. That means what is fail open means? A to close. Accordingly, you should write the controller program. Accordingly, you should write the controller program, because now if it is 8 to close, to open the cooling water, the controller has to decrease the pressure signal. Understood? Now currently the valve is operating at 30%. Now to open 35%, the controller has to send more, or let's say less pressure, because it is, if pressure decreases, then the valve opens. Air to close, increasing air pressure will close the valve. Have you understood? The controller program will be done only after selection of the valve. Write this entire points in your notes. I am going to give, let's say, 2-3 minutes time. So just digest the concepts. This is not gate point of important, but this is important if you are working in the plants. Gate point of view, the selection of the walls and all is not there. Higher the temperature, higher the signals, correct. Higher the temperature, higher the signals here. This is temperature signal, but this is pressure signal, no? Now, what is this valve? What is the feed valve? Feed is some hydrocarbon, no? Something hydrocarbon. Suppose if you let the hydrocarbon into the CSTR, then what happens? In emergency, do you allow hydrocarbon to enter into your plant? Do you think hydrocarbon entering into the plant is safe or unsafe? So completely unsafe. So this will be fail close. All feed has to be closed. Whether it increases temperature or decreases temperature is not a question mark. Whether it catches the fire or not is a question mark. Suppose if there is an emergency in the plant, cut the anything which is flammable into the plant is a simple thumb rule. Anything which is flammable should cut. Basically, most of the feeds are flammable or something. So you should cut down the feed. That doesn't mean that if you allow hydrocarbon, there will be breakdown, or let's say there will be explosion of the plant. Even if you send the hydrocarbon into the plant also, there may be not very high risk, but cutting down the hydrocarbon has a very good safety compared to not sending the hydrocarbon. So you should write all these points, whatever we have discussed, into your notes. See, everybody clear with the selection of the wall? Then we'll go to wall characteristics. So the stem types will be multiple types. The stem that you are seeing will have, this is one way. So what is this is another way. So what is another type is The valves can have this kind of multiple position. Suppose if the valve is this kind, then imagine a scenario. This is, let's say, this is my stem position. Let's say, is it fully closed or fully open? This is closed. Suppose if you lift the valve by, let's say, little bit of percentage. Suppose if you lift the valve by little bit of percentage. Then you have the most of the clearance has come. This is the clearance where it is flowing. No? Now by lifting the another, let's say I lifted only, let's say, 20%. Then valve, the clearance has come almost, let's say, 90% clear. By opening the rest of 80%, you are going to get only 10%. So if I try to draw a diagram of, let's say, flow versus percentage of lift, you get, like, every control valve has some maximum flow. You got, let's say, 80% of the maximum flow with the 20% lift itself. So that means this is the characteristics. So by 20% opening, you got almost 80% of the flow. Because the stem is designed like this. So this is called as quick opening type of valves. This is called as quick opening. This is called as quick opening type of valves. Now see this one, linear. So that means if you keep on lifting, the flow will be proportional. If we keep on opening, this is linear, this is quick opening. The other one is a equal percentage. The other one is this is called as equal percentage. This is linear, this is quick opening. Generally, we'll go with the linear equal percentage valves because, so time t equal to 0, at time t equal to 0, the valve will be like this. Now, if you operate the valves, let's say for 5 years, 10 years, 15 years, the stem will be always touching with the base. Then what happens? There will be a friction. Maybe after 10 years, the valves will become linear. Suppose if I start with linear, it will become quick opening type after 10 years of operation because of the frictional losses. So that is why generally we will go with, because why we do not select quick opening, because if I want, the valve is very sensitive. If I just to open the valve, you will get the maximum flow. Suppose if I want to operate my plant at 10% capacity, you cannot operate using quick opening valves. Then when we use quick opening valves is, suppose cooling water. Suppose let's say if you see the hydrotreater or hydrocracker reactor, so the hydrotreater reactor is surrounded by a cooling water nozzles, because suppose if there is any emergency, the cooling waters will open and sprinkle the water on the reactor so that the system will be cooled. So when there is an emergency, you can't keep on opening the valve. So you need some action which should be fast. So that is where you will use the quick opening type of valves. But generally for throttling means for adjusting. Adjusting, you cannot use the, let's say, quick opening valves. You will use either equal percentage or linear. But generally we go with equal percentage, because if we start equal percentage, maybe after some years of operation, the valves will become linear. The first one is equal percentage. This is yes, triangle shape is linear. See, why I am starting with, let's say, equal percentage is the valve is something like this. It is something like this. Because of the friction, like when the valve is opening and closing, the stem is always touching with the base, no? That means there is a frictional losses and metals. After 10 years, it becomes something like this because of the wear and tears. Suppose if I start with equal linear, because of wear and tears, it becomes quick opening. Quick opening, the main disadvantage is you can't adjust the flow. By opening a single thread, you will get, let's say, 80-90% of the flow. So that is why generally we start with equal percentage or sometimes linear. Why the valve is called equal percentage? Because the flow relationship is dq by q is proportional to x is equal to mx. Here q is equal to mx. Flow is here, percentage of change in the flow is proportional to the lift. That is why it is called as equal percentage. No, see, it is not percentage. See, if you change the valve by from 10% to 20%, the flow will also change by 10%. The change in the flow, the percentage of change in the flow is proportional to the lift. Here, flow is directly proportional to the lift. Here, change in the flow is proportional to the lift. So we have some problems, we'll solve them. This is the nature. If you take this equation and draw the flow equation, you will get like this only. So the next one, is everybody clear till now? Controller actions. This is little theory here. Suppose let's take the example of, let's say, CSTR again. So I'm going to take the same example throughout the chapter, because one example we are explaining most of the concept, then your concepts will be clear. So this is my CSTR. Now you have a cooling water jacket. So cooling water going in and coming out. Now you have the instrumentation, measurement. temperature set point. Clear? Now, suppose let's say, what is this valve type? This should be failed to open. Now the system is at steady state. This is 40 degrees. This is 1 mole per hour. This is, let's say, 60 degrees. Let's say 1 mole per hour. This is 1 ton per hour. 35 degrees. The valve opening is 30% because it's used 1 ton per hour. And this is 45 degrees centigrade. Clear? Now this is 60 degrees. System is at steady state. Now this is 60 degrees system. Let's say the 30% corresponds to, let's say, assume that 7 psi. 7 psi will give 30% of opening. 60 degrees and you are getting 7 psi. And then what is the valve opening is 30%. Suppose suddenly 60 started to increase, then what should be the cooling water opening? Percentage of opening, should it increase or decrease to bring back the 60 to back to 60? Suddenly 60 started to rise, 65, 70, 75. Then what you should do? Should you increase the opening of the valve or decrease the opening of the valve? If you see suddenly 65 in the CSTR, should you increase the cooling water flow rate or decrease? You need to push more cooling water. So the system will go to more cooling water. Now to increase the percentage of opening, what should be the pressure signal? Does the pressure signal decreases or increases? Decreases because it is air to close type. So now if with respect to controller, if you see its input is 60 degrees, its output is 7 psi. If the plant signal sends 60 degrees, it will send the 7 psi. Suppose if the 60 degrees is increasing, it decreases the pressure signal. Correct or not? If the input increases, if the temperature of the CSTR is increasing, it has to open more cooling water. So to open more cooling water, it will decrease the pressure signal. Is it right or not? Is everybody with me? Understood? Now, it's like this is the action of the controller. Suppose if I am the controller, if I see the temperature of the CSTR increasing, I should open the valve. I should increase the opening of the valve. Suppose if I am, imagine that you yourself acting as a controller. Now you are watching your eyes are your measuring element. Suppose if I am the controller, then what happens? I need to see the temperature. So my eyes becomes measuring element. So I am watching the temperature of the controller. My hand will become the opening of the valve. So now if I see 65 degrees, I will go and open the control valve. Now to open the control valve, my action is I have to decrease the pressure signal because the control valve which is sitting there is A to close type. Because see, if I'm acting as the controller, if I see 65, I'll just give a pressure signal of 5 psi. Because 7 psi corresponds to 30% opening, 5 psi will correspond to 35% of opening. So for me, if my input increases, my output decreases. Correct or not? So this is input to the, so this is if the input increases, the output is decreasing. So this is called as indirect action of the controller. Indirect action of controller. This is called as indirect action of the controller. See, if the temperature of the CSTR increases, I should have to increase the opening of the cooling water flow rate. To increase the opening of the cooling water flow rate, I have to decrease the pressure signal because the valve is failed to open or air to close. Now, if I am the controller, if my temperature is increasing, I am decreasing my pressure signal. So for controller, this becomes output, this becomes input. No. So if my input increases, output is decreasing. Is called as indirect action of the controller. Suppose if I change the valve from fail to open to fail to close, then the controller will become direct acting. Because now this will remain same. But to increase the valve opening, I should have to increase my pressure signal. What is this valve called? Air to close valves are called as indirect acting. The valve is indirect acting. Because for the valve input pressure increases, valve is indirect acting because suppose let's go to air to close. For air to close, if the pressure increases, valve or let's say valve opening decreases. So this is also called as indirect acting. Because if the pressure increases, valve opening decreases. Similarly, for air to open type, if pressure increases, opening will also increases. This is called as direct acting. This is so if pressure, so these are direct acting because if pressure increases, opening increases. Clear? Always. So have you understood how do you, let's say, find the action of the controller? These are called as indirect action of the controllers or indirect acting controllers. So tomorrow do you have holiday or you have the classes? Tomorrow do you have any office or office means college? Tomorrow is by those celebrations. No, you should have holiday. So can I take class in the same time, 9 to 11, 9:30 to 11 tomorrow? Okay, tomorrow we'll take same timings, 9:30 to 11. Tomorrow I'll take evening also. Today evening, is it possible? Today evening. I think somebody has the semester exams. Okay, today evening also we'll take the class. Today evening also maybe 4 to 5:30. Tomorrow morning also we'll take. Okay, I'll send. So today I'll take maybe 1 hour, maybe 4 to 5 or 4 to 5:30. I'll just discuss with them and take the class. Okay, then I think we can stop here. If you have any doubts, I can take the doubts. Today evening, I'll take the class 4 to 5:30 mostly. So if you have any doubts, we can clear the doubts. See, what is the controller actions is, see here, if the temperature of the CST, just think about the system. If the temperature increases, you should open the cooling water flow rate. Now to open the cooling water flow rate, the controller has to send a decreased pressure signal because it is air to close type. So if the input increases, output decreases. That is why this is called as indirect action of the controllers. So now the see, if it is fail to open type, if the temperature signal increases, pressure signal decreases. That is indirect. If the valve is failed to close, then the temperature signal increases, pressure signal also increases. Correct. In the question, valve has to be given as air to open or air to close. Without the valve, you cannot decide. Because whether controller has to decrease the pressure signal or increase the pressure signal, it should know what is the valve type. But overall, you know what is the action required. When temperature increases, you have to open the cooling water flow rate. If you have any doubts, we'll take the doubts, else we'll close. If the output is the output of percentage of opening of the volume, output is percentage of opening. Both are directly proportional. Generally, where the valves percentage of opening is with the output, or let's say flow, you can take anything. So I'll ask them to send the recordings. I think it is, I don't know how they will send our. Okay. Okay, thank you all. We'll meet in the evening.